There are 7 official SI units, but sometimes we want to measure other things, such as volume. There is no official SI unit of volume. Since volume is length times width times height, and since the official unit of length is meters, we can get an unofficial derived SI unit, which would be meters times meters times meters, or in other words, cubic meters. In chemistry, however, we typically use the liter. There's a handy conversion that we often use. 1 cubic centimeter equals 1 milliliter. We typically use cubic centimeters when we refer to solids, since we can sometimes measure solids with a ruler to find length, width, and height. We typically use milliliters when we refer to liquids. The 1-to-1 conversion makes it easy to switch from one unit to the other. There is also no official SI unit for density, but again we can derive one based on how it is calculated. The formula is density, D, equals mass, M, divided by volume, V. Our official SI unit for mass is kilograms, and our derived SI unit for volume is cubic meters. So the official derived unit for density is kilograms per cubic meter. Once again, however, chemists typically stray from the official units and use some unofficial ones instead. This is partly because, as chemists, we typically measure small things. Kilograms and cubic meters are too large. When we are measuring a solid, we use grams per cubic centimeter. When we are measuring a liquid, we use grams per milliliter. When measuring a gas, since the gases typically take up more space than liquids, we use grams per liter. We can use the density equation to solve for a missing variable. In this example, we are trying to find the volume taken up by something with a density of 1.78 grams per cubic centimeter and a mass of 1.25 kilograms. Since we are trying to solve for volume, we need to rearrange our equation to get V by itself. We can play a little math trick and make the D in the numerator on the left side switch with the V in the denominator on the right side. So our equation rearranges to V equals M over D. Rearranging equations is a key skill in this class. So if you don't know how to do it, please get some algebra tutoring, read an algebra textbook, or look for resources online. Another key skill we will use in this class is checking our units to make sure we are doing our calculations correctly. In this example, we have grams as part of our units for density and kilograms as our unit for mass. Before we put them into our equation, we need to get the units to be the same, either both grams or both kilograms. Since kilograms is by itself, I find it easiest to change kilograms into grams before plugging it in. To change kilograms into grams, I choose a conversion factor with kilograms on the bottom and grams on the top. My power of 10 for kilo, 10 to the third, goes next to my base unit of grams. My 10 to the third and my kilo are on opposite sides of my conversion factor, since they mean the same thing as each other. I take my 1.25 kilograms and multiply by 10 to the third grams, and I get 1,250 grams. Once I have the correct units for everything, I can plug my numbers into my equation. 1,250 grams gets plugged in for mass, and 1.78 grams per cubic centimeter gets plugged in for density. Notice grams cancels out with grams, leaving me with cubic centimeters in the denominator of my denominator, which can be thought of as the cubic centimeters being in the numerator for our answer. Again, please go over your algebra if you are confused as to why we can move our units around like that. Once we do the calculation, we come out with 702 cubic centimeters for our volume. In this poll question, you are using your density equation to find density of an object having a volume of 253 milliliters and a mass of 91.6 grams. Is the answer A, 0.362 grams per milliliter, B, 2.76 milliliters per gram, C, 362 grams per milliliter, or D, 23,175 grams per milliliter. We're trying to solve for density, and the equation for density is D density equals M mass divided by V volume. Since we're trying to solve for density, we want density to be by itself on one side of the equal sign, and it already is in the equation that we know. So we don't need to do any rearranging of the equation for this particular problem. So all we need to do is plug in our values. We have a mass of 91.6 grams and a volume of 253 milliliters. So to do this problem, we would do 91.6 divided by 253, and we would come out with 0.362055. And the units on that, we've got grams in the numerator and milliliters in the denominator. So our unit will be grams per milliliter. So we know that it's not B, which is milliliters per gram. And we can find the number that matches. We're looking for 0.362, and that would be A.